Hello everyone. We're on P-1 and it's example number 10. So first I'm going to show you how to solve radical equations. How to solve radical equations. So the first example is 2x plus 7 minus x and it's equal to 2. So in order to solve this radical equation, you got to do its inverse operation. If it's square root, we do square. If it's cube root, we actually cube both sides. But first, you have to isolate the radical expression, which is just this part. So I would add x both sides. It's radical 2x plus 7, and it's equal to x plus 2. Next, let's try getting rid of this radical. So I would do its inverse operation both sides. So this 2x plus 7 would stay the same on the other side. Okay, since it's x plus 2 square, so you could write it out twice like this and distribute. But I'm gonna follow a shortcut, which is a plus b squared. So anytime there's a binomial squared, this is how we expand this. It's a squared plus 2ab plus b squared. And if I follow that, it would be x squared plus 4x plus 4. Okay, if you don't like that shortcut, that's still okay. If you distribute, that would still give you the same answer. So lastly, I know it's going to be a quadratic equation because I see square expression in there. So try, by keeping this square term positive, I would just move everything over to the right side. This becomes x squared, 2x and minus 3, and it's equal to 0. Now this is a quadratic function, so I can just do x factoring to solve. So once I do x factoring, it's going to be x plus 3, x minus 1, and it's equal to 0. So set each one equal to 0, and my answer would be x minus 3. X is equal to negative 3, and x is equal to positive 1. At the end, you gotta check. So how do we check? So basically, plugging these numbers back into original problem, and if any of the radical becomes negative, it means it's going to be an extraneous solution. So that's my first example. Now let's move on to second example, which is example number 11. So I have x minus 4 to 2/3, and it's equal to 25. All right. So you can actually switch it to radical and then follow the same stuff we did for the previous example. You could do that. But if not, there's another way. So think about this. I have 2/3 as a fraction. What would you multiply this by to cancel this? Because that's what we do. We do its inverse operation. So if I just multiply this by its reciprocal, which is 3/2, that's how you can get rid of the fraction on the top. So that's what I'm going to do on both sides. But don't forget, you have to isolate that expression first. Since it's already isolated, so there's no point of doing any other step, I would just do 3/2 right away. But 3/2 is actually the exponent for that expression, okay? So on this side, it's just going to get canceled out. I have x minus 4 left on this side and 25 to 3/2 on this side, okay? I know some people might going to type it in the calculator and find the answer for the right side number, but I want you to switch it to radical first. So switch it to radical. Switch it to radical. I hope you remember the bottom number is the root of that radical, and the top number is the exponent for that. Okay, so x minus 4 would stay the same. 25, if I switch it to radical, it's going to be square root of 25. And now, this is kind of tricky. Where would you put that 3, outside or inside? So I would put outside. Why? Because radical would give you a smaller number at the first place, and then I would do to the third power. It would be easier. Okay, so I have x minus 4 on this side, square root of 25. Now, this is another thing you need to watch out for. If you take square root of a number, it's always plus and minus. So I would say plus and minus 5 to third power. This is where you need to split it into two different equations. I have x minus 4 is equal to positive 24 or 25. Oh, not positive 120. It's going to be positive 125. Why? Because 5 to the third power would be 125. Other side, it would be negative 125. And finally, I would just solve for x. So x is equal to, okay, add 4, 129. And this x is equal to negative 121. Here you go. That's how we solve these irrational exponent equations, okay? Now next example is on absolute value equations. So how do we solve absolute value functions or equations? Okay, so let's say I have, this is example number 12. Example number 12. I have x squared minus 3x in absolute value signs, and it's equal to negative 4x plus 6. Okay, I hope you remember if it's absolute value function, it's like you always have to split it into two different equations. One's always going to be the positive side, other's going to be the negative side. But again, just like radical, you have to isolate this absolute value function first. It's already by itself, so I'll just move into two different equations. One is the positive side, other side going to be the negative side. Okay, I'm not going to go in that detail because we already know why it's positive or negative, right? Because it's absolute value, distance on both sides. So for the positive side, on the left side, okay, left side of this equation would always stay the same. And the right side would also stay the same. Why? Because it's the positive side. So positive side is literally the same equation with no absolute sign symbols in there, okay? For the negative equation or the negative side, again, left side would stay the same, but the expression or the number on the right side becomes a negative. So either you can switch the signs or I would just multiply by the negative. Here you go. Either or. Just multiply by the negative or switch the sign is the same thing. Now just solve each one separately. So this is going to be, okay, let's combine like terms. I would add 4x, subtract 6x squared. So if I add 4x, this becomes x. And then if I subtract 6, and this is what I have. If I factor this out, x plus 3, x minus 2, and it's equal to 0. And lastly, x is equal to 3, and x is equal to 2. These, negative 3. For this right side, let me rewrite, let me simplify first. So this is what I have. It's 4x minus 6. Let's combine like terms. Oops, my bad. Sorry. I guess I hit something there. Anyways, x squared, it's going to be negative 7x plus 6, and it's equal to 0. Factor this out, x minus 1, x minus 6, and it's equal to 0. X is equal to 1 and positive 6. So total, I have 4 answers at the end. But lastly, you have to check like which one of these answers actually work. How do we check? You need to plug each one of these in back into original problem. So like here, so first one, let me write up the original one here. I have x squared minus 3x, negative 4x plus 6. Okay, if I plug in negative 3, so you know negative 3, you know what, I'm just going to copy it from the textbook here. So if I plug negative 3 in there, this side is 18 and this would also be 18. So that works. It works for negative 3. If I plug in 2, again, if I plug in 2 in here, so this side would be 2 and this side is negative 2. So that would not work. So that 2 is not the solution. That would be the extraneous solution. As I have 2 more to check. Then I have, if I plug in 1, so this side is 2 and that side also 2. So yep, that works. And lastly, if I plug in 6, so this side is 18, and if I look at the other side, that's negative 18, which is not true, so that's also extraneous. So you got to check at the end. So that's all about my first section. For the next section, I'll make a different